All right, these notes are going to be on function operations. So if you recall, like, order of operations that you learned way back in the day, that's adding and subtracting and multiplying and dividing and things like that. And so function operations just means that we're taking multiple functions and we're adding them together or multiplying them together or dividing or whatever. So to start with, we're going to go ahead and just write down the two functions that we're going to be working with. So f of x is the function negative x squared plus 5, and g of x is going to be the function 3x minus 1. All right, so here, the first operation we'll go ahead and do is addition. So that would be f of x plus g of x. And there is another type of notation for adding two functions together, and I like to describe it as like this is the lazy mathematician's way of writing this notation. They often write f plus g of x. And the reason I do not like this notation is because students will often say, oh, you should add them and then at the very end of the problem multiply everything by x. And that is not what this notation means. It just means f of x plus g of x, and it's kind of lazy. You just get to avoid writing an extra x in there. That's it. That's all you get to avoid, is just writing one x. Because if you notice up here, there's no such thing as a plain old f, and there's no such thing as a plain old g. So when they say f plus g of x, what they really mean is they really mean this. These two notations are identical. They mean the exact same thing. All right? So here, if I'm doing f of x plus g of x, I know my f of x is negative x squared plus 5, and then my g of x is 3x minus 1, and I am adding those two things together, so I'll put a plus in there. And here, to add these together, we just need to combine like terms. And so that means we typically we use the variables first, and we do the highest exponent first. So negative x squared should be the first thing that I write down. And then I have the positive 3x. And then I've got a positive 5 and a negative 1. And combined, that would give me 4. So that is what I get when I add the two functions together. Next, we're going to go ahead and subtract. So f of x subtracting g of x. Again, we have this other notation that looks kind of weird, and that would be f minus g of x. And honestly, as your teacher, I would ask that anytime you see the problem written like this, that you scribble it out and write it this way instead, because this way instead will keep most students from making little mistakes. So f minus g, I'm going to go ahead and start off by writing f of x down. And I'm going to write g of x down. And I know that I'm subtracting these two things, so I'm going to put a subtraction sign. And here we have to be careful because I'm not just subtracting the 3x. I also need to make sure that I subtract a negative 1. And so to make sure that we do things accurately to both pieces in that function, we need to put parentheses around that so that we make sure that we are including the subtraction for both of them. So the negative x squared plus 5, that can stay, nothing's happening to that. But here I can make sure that I distribute that subtraction sign. So I'm subtracting the 3x, I'm subtracting the negative 1, which would make that a positive 1. And now this is just like the addition problem. Now I can just kind of combine like terms. So I have the negative x squared, and then I have the negative 3x, and I have a positive 5 and a positive 1, and that makes 6. All right, next we'll go ahead and multiply these. So f of x multiplied by g of x. And when you do multiply, you might see a little dot for multiply, or they might just be written right next to each other. It can go either way. And again, we have this other notation that can be somewhat confusing written over there. So I'm going to go ahead and write f of x down. I've got negative x squared plus 5. And I've got 3x minus 1, and I know that these two things are being multiplied together, And I would not put a little multiply sign right here because then most students would probably just multiply the 5 times the 3x and that would be it. That's all they would multiply. So we need to put these in parentheses to show that we are multiplying this entire function by this entire function. Multiply them together. Now when we multiply these, you can use the foiling method or you can multiply using a box if you want. It is up to you. For the sake of the video, I'll go ahead and do both of those at the same time. So I've got a negative x squared and a positive 5, and I've got a 3x and a negative 1. And when you do it on your paper, go ahead and choose one method. You don't need to do both methods, just choose one. So first, if I was a foiling person, I would do negative x squared multiplied by 3x. So if I do negative x squared multiplied by 3x, I should get negative 3x to the third. And then if I was a foiling person, I would say negative x squared multiplied by negative 1. So negative x squared multiplied by negative 1 gives me positive x squared. And then if I was a foiling person, I would do the insides next. So 5 times 3x. And 5 multiplied by 3x gives me 15x. And then the last for foiling would be the 5 times the negative 1. And that's negative 5. And in this problem, when you're writing, if you look at the box, you can see that we don't have any like terms there. So we can really just write down what we had, and that's the final answer. I'm just going to go ahead and bring it down here in the notes so you can see it clearly. We had no like terms to combine. Okay, and then one last operation. We have f of x divided by g of x. So you can see the division problems written this way, and they might say something like f divided by g of x. You can also see these written as a fraction because sometimes we talk about division as being fractions, the numerator divided by the denominator. So f of x divided by g of x, I would say might be the more common way you might see this. I guess you can see both of them. And then over here, that other funky notation would just be f divided by g of x written like that. Now, regardless of how they give you the problem, our answer should look like this. So whenever we do division problems, I would expect to see that your final answer is written as a fraction. So here, we're going to put f of x on the top, which was the negative x squared plus 5. And then on the bottom, we're going to put the 3x minus 1. And for this unit, these are kind of easy because we're going to call it good there. We're going to say, yep, we're done. In the next unit, we're studying rational functions. This is a rational function. And when we study those, then we'll be able to do more with them at that point. But for now, that's as far as we would go.